So with solving proportions, we're gonna have some more steps here. We'll fill those in a few minutes. And a proportion, first of all, does anybody know what a proportion is? If you look at these examples, what do you think a proportion might be? Look through the notes real quick. What do you notice about every single problem? What's that? Yeah, fractions throughout the whole thing. Every single problem has a fraction on each side of the equal sign. And a proportion, we're not necessarily going to write a definition of it, but a proportion, things that are in proportion have equivalent ratios. And ratios can be written as fractions, like 4/3 or x/6. So for example, proportion-wise, an example of a proportion would be like 1/2 is equal to 2/4, right? Because 1/2 and 2/4 have the same value. And so you can think of it as like equal fractions. Equivalent ratios is more accurate, but the way that we're looking at them are in fraction form. So essentially what we're saying is that we have these two fractions that are equal to each other, and we have to figure out what value of x makes those two fractions equivalent. Same thing on number 2, and for all of these actually. Every single one of these deals with equivalent fractions. That's what a proportion is. And so in order to solve for these, we have to figure out obviously what the missing value is. And the way that we're going to do that, we've got some steps you're going to write down. But before we do that, I'm just going to rewrite question number 1. This is kind of our opening example. Rewrite question number 1 underneath where it says guided examples, and just put a little EX for example. And instead of writing 4/3 on the left, just write 4. And then equals x/6. So write that down, 4 equals x/6. Because we've solved equations like this before. We haven't solved equations yet with fractions on both sides, but we have solved equations like this. So what would we do to solve for x here? Right? We could put a 1 underneath a 4. We don't necessarily have to because it's a whole number. I mean, we could if we wanted to, but it's not something that we have to do. L? Yeah, multiply both sides by 6 because our variable x, remember that fractions are the same operation as division, right? So x/6 is the same as x divided by 6. And so we want to undo this division. So we're going to multiply both sides by 6 because with algebra, we are performing the opposite operation to get the variable by itself. And so over on the right-hand side, we're left with x, and on the left-hand side, 6 times 4 is 24. So x would be equal to 24. So what do you think we could do then on number 1 in order to solve for x? Because on number 1, we have 2 fractions, or if we think about it as division, we have 2 division problems. What's that? And the answer to that is yes. Multiply. And the answer is yes. We have to multiply both sides by both of the denominators. Because 4 divided by 3, x divided by 6, if we had to undo the division here by multiplying by 6, we'd have to do that on number 1, but we'd also have to undo the divided by 3. Basically, it's a step called clearing out the fractions. And when you clear out the fractions, you have to multiply both sides by both of the denominators. And if you get to the point where you can do this in 1 step, that's great, but I'm going to write it out as 2 steps. So just to keep it very straightforward. Step number 1, let's just say multiply, write pretty small because these are going to be kind of long sentences. Multiply both sides by the left denominator. Step 2, multiply both sides by the right denominator. And then step 3, solve using variables on both sides steps, which was from 2 lessons ago, right? So that would be the steps of if you can distribute, you should distribute. If you can combine like terms, you should combine like terms. Make sure all the variable terms are on the same side of the equation, and then finish up with a 2-step equation. So this step number 3 really kind of involves 4 steps, possibly as many as 4 steps. So the 2 new things here, step 1 and step 2, basically, and they're essentially the same thing, but we have to multiply in order to make this work. So with number 1, we're going to start by multiplying both sides by the left denominator. So that would be 3. So we're going to multiply by 3 on the left and by 3 on the right. Now on the left, the 3 will cancel out with the 3. On the right-hand side, we're going to take our whole number 3, and we're just going to multiply it by the numerator. Because when you multiply a whole number by a fraction, it only gets multiplied by the numerator. So we're going to have 4 is equal to 3x over 6. And if you're thinking, could we reduce this fraction? Yeah, you could. That's something that you can do. It's not something that you have to do, but you certainly can, because it'll all reduce out in the end anyway. So if you want to reduce that, you can, but you can just work through it. And by the time we get to the end of the problem, it won't have made a difference. So now we're going to multiply both sides by the right denominator, which is exactly what we did when we solved our little example to begin with. So multiply by 6 times 6. And so now instead of having 24 is equal to x, we're going to have 24 is equal to 3x. And then from here, it says solve using variables on both sides. Sorry, on both sides. Steps. Variables on both sides. Which would be distribute if you can. There's no distributing here. Combine like terms if you can. There's no combining like terms here. Move everything with a variable to one side. Yeah, that's already happened. So this first example doesn't have a lot of extra steps once we've multiplied both sides. That's for a reason, it's just to get us seeing what needs to happen. So the last thing we're going to do is to solve for x. So we actually have to divide both sides by 3, which means that x is equal to 8, because 24 divided by 3 is 8. So what we're saying is that the fraction 4/3 is equal to the fraction 8 over 6. So those two fractions would be equivalent. All right. Stop me if you have questions, but otherwise we're going to keep moving on. All right, problem number 2. We're going to multiply both sides by the left denominator. So multiply by 10 on both sides. So times 10, and then times 10. 10s cancel out on the left. We're left with the numerator of 2. On the right-hand side, we multiply the whole number by the numerator. So that'd be 40 over n plus 5. Now, here's the next question. What do we know about this denominator in terms of order of operations? What do we know about that denominator? Think about order of operations real quick. What's that? Well, we will eventually subtract 5, or maybe it won't look like 5 when we subtract it, but could we subtract 5 as this is currently written? Are we allowed to do that? No, why not? This n plus 5 down here, what is this? It's a group. N plus 5 is a group. So I'm actually going to make a note right here. That's a group. I don't know why I'm being so dramatic, or I guess fake dramatic, because that wasn't really dramatic. Multiply both sides by the denominator. What that means is when we multiply this on both sides, because it's a group, how do groups usually look? In most cases, what do groups generally look like? What do they have? Parentheses. Yeah. So I'm going to put parentheses around that n plus 5. That's going to be really, really important, because when I multiply both sides by n plus 5, that means I have to distribute. Everybody see that? N plus 5 times 2, that means the distributive property has to happen here. Now we can do the distributive property. I'm going to cancel out the n plus 5s over here because those just cross each other out, just like any other fraction would with a numerator and a denominator. And then we're going to use the distributive property. We're going to distribute this 2 to the n and to the 5. Because we have a group multiplied by a number, which means we have to distribute. So on the right-hand side, we have 40. And on the left-hand side, we have n times 2, or 2n, plus 5 times 2, which is 10. So we're clearing out the denominators so we can just deal with regular numbers, basically. So now we've got, let's see, we've distributed, there's no like terms to combine. We've got everything with a variable on one side of the equation already. So now we just have to finish solving. So what's our next step here? What's our next step here? Solving for n. What are we going to do? Subtract 10, yeah. So minus 10, minus 10. I'm going to run out of room, so I'll just move over here. So the 10s cancel out, and I've got 2n. Just going to go over here. 2n equals 30. 2n equals 30 because 10s cancel out. 40 minus 10 is 30. Good one. Excellent. Spirit count. Who's dressed like a teacher today? I dressed like Mr. Lin.
Oh, you dressed as Mr. Lin.
I did. So.
Do you have freshman and sophomore junior?
I think all of the above. Is anybody dressed up today?
Freshman.
Anybody? Anybody at all?
Sophomores.
Oh, yeah. Get your decades day together for tomorrow. Thank you. All right, so we're dividing by 2 to finish this off. Divide by 2. 2's cancel out on the left. 30 divided by 2, n equals 15. All right. Okay. Now, some of you might have been able to look at these first two and just figure out what the value was, because 3 to 6 is times 2, right? And 4 times 2 is 8, so that makes x equal to 8. On this one here, 2 to 4 is times 2. 10 times 2 is 20, so what do you have to add to 5 to get to 20? That would be the answer here, 15. So you can kind of use just some basic logic and reasoning to work these out, but the process is going to be really helpful because once we get into the more complicated ones, knowing the equation solving process is going to be a lot more useful than perhaps it was for these first two. So let's look at number 3. So step number 1, what do we do? We wrote it down just a moment ago. So what's step number 1? Multiply both sides by 2. Good. So times 2 here and times 2 on the right. Now, on the left-hand side, the 2's cancel out. So we're left with y minus 3. And on the right-hand side, we're going to multiply the number by the numerator. 2 times y is 2y, and then over the denominator of 5. So that's step 1. What's step 2? Multiply by 5 on this one, on both sides. So multiply by the right denominator, so times 5. And when I multiply by 5 here, take a look at the original y minus 3 on the numerator. What is that? Just like on number 2, what is that? That's a group. So I'm just going to put that in parentheses to begin with, because when I multiply it by 5, I have to distribute. So anytime you have a numerator or a denominator with addition or subtraction in it, it's going to be a group. So you're going to have to use the distributive property if you multiply by it. So we'll distribute the 5, and that'll give us 5 times y is 5y. 5 times negative 3 is going to be minus 15 equals 2y. Okay, so we have multiplied both sides by the left denominator. We've multiplied both sides by the right denominator. We've distributed. There's no like terms to combine. What about moving everything with a variable to one side? Because this time we have variables on both sides. And I'm going to suggest not moving your variables to the left. I'm going to suggest moving them over here. The reason why is because the only regular number left in this problem is right here. It's the minus 15. And if we moved everything to the left, we then have to take the minus 15 and put it over to the other side, adding an additional step that we don't have to do. So let's subtract 5y from both sides. So minus 5y minus 5y. And when we do that, the 5y's cancel on the left, and we're left with negative 15. And on the right-hand side, 2 minus 5 is negative 3. So that equals negative 3y. And then the last thing we're going to do is divide both sides by negative 3. So that means that y is equal to negative 15 divided by negative 3, which is positive 5. So y equals 5. And if you think about this, if we plug it back in, if y is equal to 5, 5 over 5 is equal to 1, right? Which means that this one over here has to be equal to 1 as well. So 5 over 5 equals 1. 5 minus 3 is 2, and 2 over 2 is also 1. So that works. This one is quite a bit more challenging if you try to just use some basic reasoning and logic to figure it out. Number 1 and 2, not too difficult to do that, but on this one, it's definitely good to have this process down. All right, number 4. The top, 2k minus 3, that is a group. I'm going to put that in parentheses. The bottom, k plus 9, is also a group. I'm going to put that in parentheses. Anytime you have adding or subtracting on the numerator or the denominator, just go ahead and start off right away by putting that in parentheses, because chances are you're going to end up distributing. All right, what are we going to do first here? Step 1. Multiply both sides by what? Yeah, the left denominator, k plus 9. So multiply by k, I don't know why I wrote 5k plus 9. Those will cancel on the left. And then on the right, times k plus 9. All right, which means on the left-hand side, we have 2k minus 3. And on the right-hand side, we're going to multiply the numerator by k plus 9. And because it's a group, that means we are distributing. So that would be 3 times k, which is 3k, and 3 times 9, which is 27, all over 5. Because we still have that denominator to get rid of. Next step, what are we multiplying by now? 5. Multiply by 5, so times 5. And then on the left-hand side, times 5, 2k minus 3, though, remember that is a group as well. So we're going to take our 5 and distribute it to the 2k minus 3. 5 times 2k is 10k. 5 times negative 3 is minus 15, or negative 15. And then we have 3k plus 27 over on the left. All right. So we multiply both sides by the left denominator, multiply both sides by the right denominator. We've distributed. There were no like terms to combine, so we didn't have to worry about that. Now we have to move everything with a variable to one side. So this time we can just subtract 3k from both sides to move everything with a variable. So minus 3k, minus 3k. And so that'll be 7k minus 15 equals 27. I'm going to go ahead and move that up here. What happened? Uh-oh. Did you find out where? Everywhere. Uh-oh. Okay. What's our next step? We got 7k minus 15 equals 27. Add 15. Yep. So plus 15, plus 15. 7k is equal to 27 plus 15, which is 42. And that'll make our answer pretty nice, because when we divide both sides by 7, what does that give us? K equals what? 6. K equals 6. Nice. Okay. So Now that we've seen this process a few times, I want you to try the next 6 problems. Try the next 6 problems. See what you can come up with. And let's say, I'm not going to give too much time because we do have a second page to go through here. The ones on the next page, though, we'll do together. But I want you to try these 6. Work through them. See what you come up with. And in a few minutes, like I said, I'm not going to take too long on these ones. See how many you can answer. And then we will move on to that second page. Let's go ahead and have a look at those answers. I'll unfreeze my page here so we can see what's going on. All right, so number 1. Multiply both sides by the left denominator, which is multiplying by 8. So the 8's cancel on the left, and we multiply by 8 on the right. We multiply 8 times x, numerator times the whole number, so that's 8x over 3 is equal to x plus 10, which means x plus 10 is a group. We're identifying this as a group first. Nice job on all your answers, by the way, because if you hadn't identified those as groups, you would not have ended up with the right answer. So well done. That means you distributed. 3 times x plus 10 is 3x plus 30 because 3 times x is 3x, 3 times 10 is 30. Then once we do that, we're going to end up with 3x plus 30 is equal to 8x. Subtract 3x from both sides, and we get 30 equals 5x. Divide by 5, and x is 6. I'm going to give you a few minutes to get these written down. I know it's a lot of, like, it's very cluttered looking. I get that. There's not really a whole lot of room to show the work on these ones, so I apologize for that. We are not, by the way, once we get these 6 written down, we are not going to do everything on the second page because there's so many more to do, and I want to make sure you have time to work on your assignment today. There are 12 questions on your assignment, so far fewer on the assignment than on the notes for today. But once you get these finished in terms of writing these down, copying those down with the answers, we'll go ahead and move on to that second page. And I'm going to just pick some ones from the second page to focus in on. So here's 3 and 4. There's 3 and 4. So make sure you get these written down if you don't have them already, and I'm going to give you about 2 more minutes on that. I'm going to scoot down so you can see 5 and 6 as well. So get those finished up, copying those down, and then we will move on to the second page, and we're only going to do 5 of them on the second page. So most of them we're not going to do. We're not going to go in any particular order on the back, so I'll let you know which ones to cross off. Does anybody need more time? Anybody need more time to get these down? No? Okay. These will be posted to Google Classroom later, so if you need them, feel free to grab those later. So, moving on to the second page. I'd like you to cross off 7, 8, and 9. We're going to start with number 10 on the second page. So cross off 7, cross off 8, cross off 9. We're not going to do any of those. Starting here on number 10. So page 2, starting with number 10 here. What will we be doing first on number 10? Do what? Multiply by the k minus 1. Good. So multiply by k minus 1 and by k minus 1. I'm going to make sure that I identify all of those as groups. So on the left, k minus 1s cancel out, and I've got 6. And on the right, I need to distribute the 8 to the k and to the minus 1. 8 times k is 8k. 8 times negative 1 is negative 8, all over k minus 6. All right, then we can multiply both sides by k minus 6 and k minus 6. So on the right side, they cancel out, and on the left side, we distribute the 6 to the k and to the minus 6. 6 times k is 6k. 6 times negative 6 is negative 36. That equals 8k minus 8. All right. So we multiplied both sides by both of the denominators. We've distributed. Now we need to move everything with a variable to one side. I'm going to subtract 6k from both sides this time because I like to keep my variable terms positive. And so that'll give me negative 36 is equal to 2k minus 8. 2 more steps, add 8 to both sides. And that's going to be negative 36 plus 8 is going to be negative 28. Equals 2k. Divide by 2. And k is equal to negative 14. Plus k equals negative 14. Again, if you have questions, make sure you're asking, because this is definitely have some new things going on today, and we're definitely combining multiple skills that we haven't really put together before. So if there's something on here that is causing some issues, I guess would be a good way to put it, let me know. Happy to try to clear up any confusion if there is any. If not, we'll definitely keep moving along, but let me know. All right, next one is number 11. Got some groups over here, y minus 7, y minus 9. So we'll start by multiplying both sides by the left denominator, which is the y minus 9. So those cancel on the left. On the right-hand side, y minus 9, distribute 3. So we got y minus 7 equals 3y minus 27 over 4, because we still have that denominator. Now we multiply both sides by the right denominator. So times 4, those cancel. Times 4 on the left. Distribute the 4. That's 4y minus 28 equals 3y minus 27. Subtract 3y, subtract 3y. 4y minus 3y is 1y, but 1y is the same as just y. So I'm just going to write y minus 28 equals negative 27. And then we'll add 28 to both sides, which means y equals 1. All right, we got 3 more to go. 3 more to go. Number 14 is the next one we're going to do. So we got 10, 11, skip 12 and 13, go into 14. Any questions on 10 or 11 before we take a look at 14? All right. So number 14, start off by multiplying both sides by the left denominator. So we got 2x minus 8, x minus 6. Those are our two denominators. They're both groups. So 2x minus 8 cancels on the left times 2x minus 8 on the right. Distribute the 3. So that's going to be 7 equals 3 times 2x is 6x. 3 times negative 8 is going to be a negative 24 over x minus 6. Now we can go ahead and multiply both sides by the right denominator. That's x minus 6. So those cancel on the right. And then x minus 6 on the left means we're going to distribute the 7. So that's going to say 7x minus 42 equals 6x minus 24. Something else kind of convenient happens on this one. When we subtract 6x from both sides to get everything with an x to one side, same thing happens as on number 11. 7 minus 6 leaves us with 1x, and 1x is the same as x. So that's x minus 42 equals negative 24. And the last step, plus 42. So x is equal to positive 18. X equals 18 for number 14. All right, 2 more to go. So number 15, multiply both sides by the left denominator, 3u plus 7. Cancels on the left. Multiply by the 3u plus 7 on the right, which means we're distributing a 3. We've got 2 equals 3 times 3u, that's 9u. 3 times 7 is plus 21. I'm gonna make sure that looks like a u and not a w. All over, so we still have a denominator here, 4u plus 9. Now we have to multiply both sides by that, 4u plus 9. Which means we're distributing a 2. 2 times 4u is 8u. 2 times 9 is 18. And we got 9u plus 21 on the right. Now again, something kind of convenient happens with our variable terms because they're only 1 apart again. I'm going to subtract 8u from both sides this time, because I like to keep my variable terms positive. So that'll be 18. 9 minus 8 is 1u, or just u, plus 21. And the last step, minus 21 from both sides. 18 minus 21 means that u is equal to negative 3. Or if you want to have negative 3 equals u, same thing. Negative 3 for you on number 15. All right, try the last one on your own, number 16. Take a couple minutes on it. let's take a look. So 3 was given, 3 is the answer. Here is how and why. Starting off here, we have multiplication of 5 on both sides because we have to multiply it by the left denominator first. 5's cancel on the left. Distribute the 5 to the 3x plus 1 on the right. So on the left, you got 2x minus 1, and then 3x times 5 is 15. 1 times 5 is 5 with a denominator of 10. Then we multiply both sides by the right denominator. So multiply by 10 over here, cancels out. 10 on the left distributes to the 2x minus 1. 10 times 2x is 20x. 10 times negative 1 is negative 10. And on the right-hand side is just 15x plus 5. Now we have to move everything with a variable to one side. So subtract 15x from both sides. 15x is canceled on the right, and you're left with 5. And on the left, 20 minus 15 is 5x minus 10. Add 10 to both sides, and you get 5x equals 15. Divide by 3, and divide by 5, and x equals 3. So that is it for our notes for today. Hopefully you feel like this is a pretty repetitive process. When things feel repetitive, that is a good thing in math. Generally means that you know what to do if it's feeling repetitive.